All right, more conservation of energy here. In this one, I'm going to actually solve part B here. Right, what is its height when it's going 780 meters per second? So we fire it up from the surface of the moon going 1,050 meters per second. At some point, it's going to slow down to 780 meters per second, right? So here it is, leaving the surface of the moon at 1,050, right? And then at some height above the surface of the moon, this is of course going to require subtracting the radius of the moon and being clever, right? At some height, it's going to be going 780 meters per second, okay? So that's meters per second. So let's just set up our equation here, right? When it's on the surface of the moon moving 1,050 meters per second, its energy equation looks like this. 1/2 0.0028, because it's 2.8 grams, right? Times 1,050 squared. This is, of course, our kinetic energy, right? Plus the opposite of G times the mass of the moon, because we're leaving the moon, right? 0.35 times 0.0028. And then when we're leaving the surface of the moon, of course, we are the radius of the moon from the center of the moon, right? So 1.737 E6, that's how far we are from the surface. So this is the bullet. It's kinetic energy leaving the surface of the moon. And then remember, it's negative because it's down in that depression of the sheet of rubber, right? Okay. And then when it's going 780 meters per second, it's some height, right? We're trying to find this height. Okay. Its kinetic energy is, of course, 0.0028 times 780. Right? And then we can figure out well, what we can do, we can't figure out the height directly, but we can figure out how far it is from the center of the moon. So the opposite of G times 7.35 times 0.0028. And then that's going to be divided by R. And then once we find that radius that it'll be higher, it'll be above the moon. We have to subtract the radius of the moon to figure out the height above the moon. Okay? So, yeah. All right. So let's do some maths. Before we do that, notice that in these types of problems with gravity, inertial mass is the same as gravitational mass. At least we're pretty sure it is. Okay, so I can cancel out this mass from every term, and that's legal. I know I can do that. Okay, so I'm just going to do it without that factor in each of these terms. Okay, so here we go. Let's see, 0.5 times 1,050 squared, 551250. Okay, so hold on. All right, plus, and then let's do this term. Opposite of 6.67 E minus 11 times 7.35 E 22. Oops. I made it to the negative 111. All right, here we go. Okay, and then divided by, and then it's on the surface of the moon, so it's divided by 1.7 E 6. And this is the opposite of 2,000,000 0.149 approximately. Sorry. All right, now let's do this term here. Do I cross that off? Okay, so 0.5 times 780 squared. This is 304 plus yeah, okay, so plus this term, right? I guess the opposite of 6.67, e minus 11 times 7.35, e 22. That's approximately the opposite of 4.90245 divided by, oh, and that's times 10 to the 12th. Don't forget that, right? Divided by r. Okay. All right, so now we're all set. I'm just going to solve for, I guess I'll solve for r here. Okay. Come on, baby. Only lets me go down. I can only go down. Okay. Okay, so here we go. So let's take that guy. There we go. Plus this guy. And then I'm going to subtract this guy. Kinetic energies are always positive. All right, here we go. And then this is the opposite of and that equals there we go. All right. Okay, so here we go. So now, I guess we just do this divided by that. Okay, so that guy divided by this guy. I'm just double checking here. Okay, is r. So r is, r is 1,903,630.357. So that's how far we are from the center of the moon. How far are we above the surface? I think we have to subtract. Right, because that's our radius of the moon. This is that's our 1.737 times 10 to the 6th, right? So let's subtract 1.737 E6 to get how high we are above the moon. And I get that this is 1,666. Sorry, 30.357. All right. Oh wait, I'm putting the commas in the wrong place. Ignore that comma. All right, so there we go. So it would be 166.6 kilometers, right? So you could write the answer 166.6 kilometers. You could write it 1.666 times 10 to the 5th. Is that right? 1, 2, 3, 4, 5. So unhelpful, these calculators. Meters, right? Just be careful when you're doing this and you want to find the height above the moon. You need to subtract the radius, okay? There you go. Hope that helps.